Hello again. It's good to see you all. Welcome to today's webinar titled Large Tiled Demand Flat Substrates. You cannot make up for it with Mortar. That's a great title. I'm Jim Olson with the National Tile Contractors Association, and I want to welcome you to today's webinar, and also thank you for taking the time out of your busy schedule to attend today's webinar sponsored by Laticrete International. Before I introduce today's speaker, I want to remind you that during the webinar, you will be muted. Please use the questions area on your computer to type in your questions, and we'll answer those questions at the end of this presentation. If the audio on your computer is poor, call the number on the invite to this webinar and listen on your phone. All of our NTCA webinars are available to watch at any time on the NTCA YouTube channel shortly after the webinars are presented. This will give you easy access to watch and or share all current and past programs at your convenience. All right, today's presenter's presenting from Wales, United Kingdom today, so I want you all to pay attention, okay? Listen, and he'll have some great stuff for you. Today's presenter is Joe Rizo. He's the Director of Sales for Concrete and Substrate Preparation at Laticrete International. He leads the efforts of the United States and Canadian teams in the sales of surface preparation, moisture control, and the SuperCap network of mobile pump trucks for high volume, rapid delivery of self-leveling underlayments and overlays. Joe graduated from NYU Polytechnic University with a BS in chemical engineering. His perspective on flooring and concrete has been honed by the contractors and architects that he has had the privilege of working with over 25 years. Joe, I'm really looking forward to this. Welcome, and I'll talk to you in a little bit.
Thanks very much. Thank you to the NTCA for the fine work that you all do, and really providing so many tools for the industry. It is both a pleasure and an honor to be here today. I am in Wales, although that's not, I'm not out of the United Kingdom. I am based in New York, pretty close to Laticrete's home office in Bethany, Connecticut, which is in the New Haven area, here for a few days, and super happy that I was able to get a good internet connection and a mostly quiet place to speak to you all and to present. So having said that, I would like to dive in and begin our short endeavor for this evening. A lot of presentations, a lot of talk is done for concrete preparation, substrate preparation when it comes to flooring, but there's a little bit of a prevailing attitude, particularly in years gone by, that there is more of a need for substrate and surface preparation for other types of flooring than tile. As we're going to see today, it's going to be, it's becoming more and more important, and has been over the last few years, to have a very good, high quality, hard, flat substrate in which to put tiles and tile installations on. So as we were saying, I took a picture of this section at the Albert and Victoria Museum in London, and this is literally just a few days ago when I was there, and I passed by this display which shows a tile installation at some noble's house in Italy from the very early 1500s. Now, I could have picked any picture as an introductory picture because let's face it, tile installations are famous not only for their beauty and their functionality, but also for the long-lasting durability that they offer. And we can go back into history for millennia, not just for centuries. But I thought it was so appropriate in this gigantic museum, which had so many different types of exhibits, from rare fine art to modern kitsch, and right there, I found it a little bit of a symbolic thing, showing how what we do, what our industry does, is important and changes people's lives, and that we have these amazing installations that last and last and last. Um, this long history um, is dependent on great installation. It's not just the tile itself; it's the way tile is installed, and that is possibly more important than even the materials themselves. There is no way to take a great material and have it serve its purpose if it's installed incorrectly. And tile artisans have always had the capability to do this very well. Uh, we are still there. We are still at a time and a point where tile installers are tremendously talented artisans. And that hasn't changed. Sometimes you hear people lament, "Oh, it's not like the good old days." When I can say for a fact, I can attest to the fact that our tile installers are great at what they do and perform wonderful work. What's getting better as time goes by is the fact that the technology and the innovation that exists is helping the installers, these artisans, do their work in such a way to get even more functionality, more durability, and a longer life from the installations that we're seeing today. One of the trends that is very, very prevalent um, is that tile is getting bigger. Certainly in my 3 decades in the industry, I have seen, and not only professionally, right? I'm talking about, I've seen it in my very own house, where my first kitchen as an adult many years ago, we had 12-inch by 12-inch tile. And the next place a few years later, we went to 12 by 24s, and we're seeing a, an emergence of these beautiful artistic expressions in tile, where the individual pieces are getting bigger and bigger. But this also demands that the substrate on which the tile sits on has to be of a flatness and of a durability, frankly, to be able to get the intimate contact between the mortar and the tile that is so necessary for a long-lasting, strong application. ANSI, which is the American National Standard Institute, has a document 108, which is actually a series of many, many documents that talk about the installation of tile. A standard tile, which is defined as any tile which has 15 inches or less on all sides for the dimensions of the tile, the deviation that is allowed is 1/4 of an inch every 10 feet in a 10-foot area, I should say. What possibly might even be more of a challenging is that in a 1-foot section, no more than a 1/16 inch deviation of height is allowed in a 1-foot area. This is measured with a straight edge from the highest point. So essentially, if we are to lay down a straight edge across a 10-foot area, a 10-foot straight edge, we should not see more than a 1/4 inch gap in 10 feet of that straight edge. LFT, which is large format tile, is defined where the tile has even one single edge that is 15 inches or greater. And again, that is dealt with in ANSI 108. There, the measurement goes down from a 1/4 inch deviation from the straight edge at our high point to 1/8 of an inch in 10 feet, and a 1/16 of an inch maximum deviation in 2 feet. These are highly, highly demanding substrate requirements, and they're not always the easiest to achieve. What we're going to talk about today is how they can be achieved every single time, and frankly, why the tile installers can be part of achieving that by having the substrate preparation in their bid. Let's look at concrete for a little bit. Concrete is the substrate that our tiles very often sit on. It's not the only one by any means, but it is one of the popular ones. ACI 117, and ACI is the American Concrete Institute, says that a concrete pour can have a deviation maximum of a quarter inch in 10 feet and allows for a 1/8 inch local deviation without defining what local is, but generally accepted as within a 1 foot area. That is given a number FF, where FF stands for floor flatness. A very important note to make is that the deviation for allowable for tile and for other types of flooring is defined by the architect, usually in division 9 of the specification, the flooring specification. Sometimes they will and should be also in the tile specification. Concrete is in division 3. Unlike the flooring and the tile specifications, which are typically implemented and authored by architects and specification writers that work with architects, the concrete is defined by a structural engineer. A structural engineer's primary focus on defining concrete and giving the parameters that are necessary are much different than what we're looking at for tile installations. They're looking for a strong, high PSI, possibly freeze thaw and outdoor applications, all sorts of specifications that are structurally driven. Therefore, an FF of 25 is really quite sufficient in what's being done. However, it doesn't even come close to what the requirements are for LFT. This graph shows a correlation, and it's a rough correlation between FF numbers and deviations from a straight edge. So division 3 concrete are FF of 25. You can see on our graph here, the FF number is our horizontal axis, our x-axis, and quarter inch gives us our FF number of 25. When we're looking at tile installation requirements of the 1/8, that is an FF50. And by the way, the numbers are linear. What that means is that by the definitions that we just gave, it is twice as flat. An FF50 is twice as flat as an FF25, and that's how it goes. And that's an important note to make. There is a big discrepancy there. Part of the discrepancy is a lack of understanding between the structural community and the flooring and tile community in talking to each other. And again, the reason that I brought up that one is done by an architect, the other by an engineer, is to show that it's not the same people in the same room that are writing these specifications. As a matter of fact, more often than not, it is not only different people, different disciplines, but different companies entirely. So this is how we have a situation where you show up on a job and you find a floor that comes nowhere near what you need to install tile. And the tiles keep getting bigger, and that's a great thing. It's again a truly artistic impression that can be left by a very large panel. What used to be called thin tile or thin porcelain tile a few years back is now more officially and more properly referred to as gauge porcelain tile panels. And a panel is anything that's larger than 36 inches square. So that is getting into a sizable, a 3x3, a 3 foot by 3 foot piece of tile has 9 square feet of area. A 4 foot by 4 foot is 16 square feet. So you can see we've got an amount of surface area that is significant, that if the substrate does not meet the flatness levels that it's supposed to meet, it will not have an application that is going to be durable, lasting, or strong. Some of these panels are now over 10 feet in diameter, over 10 feet in single dimensions. The ANSI standard that deals with these is 108.19. And there are unique installation and transportation methods for some of these very large panels. Now, the flatness tolerance is the same as LFT, 1/8 and 10, and 16th in 2 feet locally. But there is an informative note right in the standard that surface prep is critical and should be included with the bid, or at least an allowance made in the bid, where the installing contractor who is bidding has the opportunity to say, I recognize and you recognize that this substrate very likely will not meet these stringent requirements for these very large pieces. In order to judge all these bids on an even basis, there has to be an allowance in the bid for surface preparation. And that's a very good thing for our industry, that recognition by the organizations that deal with these sort of things. The NTCA has some great training programs and has been working with GP panels for a number of years. It is a little bit of a different world. But what we can see is, regardless of whether we're doing smaller tiles or large format or GP panels, there is a need, more than what has been discussed, that the substrate needs to be flat in a quantifiable way. So who's responsible for flattening and leveling the slab? Is it the concrete contractors? Possibly, if there's a rider in the specification for the concrete that says the concrete needs to be above and beyond the standard concrete spec, so that it is floor ready, it is tile ready. More often than not, we don't see that kind of rider. So is it on you, the tile installer? Possibly, but not as an onerous thing. As an opportunity to perform a valuable and necessary function, it is either anticipated, as has been recommended in 108.19, that substrate preparation is going to be necessary, or it's a change order. Either way, it is a money-making opportunity. The NTCA and the TCNA give clear-cut recommendations on how the substrate can be brought into a condition which is acceptable. Self-leveling, which is the basic topic of our conversation tonight, is one of the first that's shown. Bonded or unbonded mortar beds can also be used depending on the application. If it's a floor that shows a lot of localized high spots, grinding is part of the preparation that can be necessary and beneficial. There's one which is an interesting statement to me, where it says increase steel reinforcement to cross-sectional area. That's awesome, but how often do we in the tile industry get a chance to do an inspection of the concrete when the rebar is down before the concrete is poured? So that particular one is great if we can catch it while the slab is in the design phases, not when the project is in construction, when it's very typical for us to be looking at it. The organizations recommend the specification and installation of self-leveling. And there is a very important note, which I bolded out. Thin set or medium bed mortar may not be used for truing or leveling, because of the large nature of the tile and the large expanses of the substrate. The accuracy that's needed will not be achievable by using mortars that are meant for tile installation. It was an important enough point that the organizations make, that the NTCA makes very strongly in the manual, that I included as part of the title of this presentation. So the opportunities that are created are for us as an industry to be able to do the preparation that's required. However, that understandably is not always in our comfort zone, in our bailiwick, in our carriage wheel. However, with education, with help, with understanding of the specifications and support, there are a number of ways that you as a tile installation contractor can get involved in this, and frankly, it can be lucrative. So not only is it not a negative, but it is an opportunity to increase a bid size and control more of the work in a project. So one of the methods is for a well-trained contractor to self-perform the self-leveling, or they can subcontract or partner with SLU application contractors, SLU standing for self-leveling underlayment. I try as much as I possibly can to define whatever jargon I use. And finally, in conjunction with a subcontractor, there are pumping services that employ very large pumps that can get wet material at the end of a hose exactly where it's needed to perform the pumping and installation of the self-leveling. It's a different way of handling a subcontract for applying self-leveling. I do want to take a brief moment to discuss the difference between FF, which is floor flatness, and floor level, and it's particularly important if you are considering or you do bid on a regular basis already for floor flattening, substrate preparation, and remediation. Floor flatness tells us how wavy or how bumpy a concrete floor is. It's about local deviations. It's about a substrate that is simply not smooth. It can be level, but not necessarily smooth. So technically, what's measured in quantities is the height of the waves, fancy way of saying how big the bumps and lumps and areas are, and the wavelength, the distance between the waves. And that's why we talk about 1/8 inch in 10 as a deviation from high points. Floor level, on the other hand, actually tells us, is the floor on point with the horizon? Is it at a particular elevation that's in relationship to door jambs and elevator box? Is it on a slope because it's sloping towards a drain? Two very different characteristics, sometimes measured similarly, sometimes not. There are different American Standard test methods, ASTM test methods that deal with both of these. But it's good to know the requirements, and I will give you an example. I was recently on a large project in Florida where there was an FL as well as an FF requirement. The owner had decided that they wanted the floor to be at an elevation, a particular elevation measured off of the building itself. What that meant was that even though the floor could have been flattened, and I'm throwing out just a number, with a 1/4 inch depth of self-leveling that was applied, that would have been as high or higher than any of the local deviations as defined by floor flatness. Because the floor had to be at a particular elevation, the pour ended up being over an inch instead of just being a small fraction of an inch. So that one little letter, L versus F, can make a tremendous amount of difference on the requirements. There is a place for wet set, tile, and mud beds, of course, just because this presentation deals with mostly self-leveling as a flattening method for preparing the substrate. Wet set, as shown here, is a method which is still used, particularly regionally, mostly in Florida, where this is. Now, not necessarily the easiest way of performing the function. However, because this particular installation was not a porcelain installation, it was a natural stone installation where the pieces were not rectified. So a flat floor would not necessarily cover all the gaps because you were dealing with a stone that wasn't flat. Um, However, there is technology and there is innovation that does take into account that not all labor markets are the same as what the Florida market used to be, where it was easy to get uh, labor that often is less expensive than in other parts of the country to do field mixes. There are prepackaged products that are available. There are polymer modified products to set a bed, and of course mud beds in parts of the country are still popular methods for creating a slope in a shower, particularly where you have a dramatic fall down towards a drain so that the water can drain away. One thing to be said about self-leveling, and we'll define that term because the industry has had a lot of questions and a lot of discussion about that. But one thing to say is that it does want to go towards a flat situation. You can maintain a small amount of slope on even a self-leveling material, but if you're looking to slope dramatically, using a self-leveling might not be the best way to go. So what is a self-leveling underlayment? It's a highly flowable mortar that doesn't need a lot of finishing. It provides a flat, hard, strong surface that you can put tile or other flooring materials over the top. Starting backwards, a word underlayment defines right there that it is not meant to be a final surface. There are self-leveling overlays, again, not the topic of this discussion. But we can certainly provide any information on overlays as well. Here, we're looking at a material that goes down like a pea soup or something very liquidy and finds not a level, but it does tend to go towards flatness. So I remember when 10819 was being written, and there was a lot of questions. Well, should it be called self-level? And the answer to whether it really is self-leveling is of course not. If we take the definition that the industry gives to level, a cement-based powder inside a bag when mixed with water does not know by itself how to find a particular level. There are no microchips. I know that surprised a lot of you, but there's no microchips that tell it what level it needs to be poured at. I can say this, current generation SLUs flow better than they ever have before. The better ones, the best ones are so liquidy that they do approach self-flattening. You might even call them self-flattening at the right thickness where gravity is helping move them along. Hitting an FF and an FL depend on measuring elevations at different points in the slab to which the material is poured. And frankly, with the right measurements, the right pre-work, and the appropriate material, very flat, super flat, and level floors can be achieved. The level would come in the elevation measurements being done to a particular benchmark versus being done relative to the floor itself. ANSI 11816 and 10821 define self-leveling underlayments, also use the expression, the terminology, flowable hydraulic cement underlayment, because there was a discussion, since it's not self-leveling, shouldn't we have a different name for it? A decision was made to give a more technically appropriate name, flowable hydraulic cement underlayment, but to keep the commonly known and understood self-leveling underlayment moniker. One thing to keep in mind is that other portions of the flooring industry the soft, resilient, and so forth floors do use that term, as do the manufacturers. So self-leveling has been used as a term for the better part of 5 decades, and hence it was kept after discussion in the specifications. But it is important to understand what it implies and what it does not imply. Okay, so what are the consistencies of self-leveling? Here we have a highly flowable self-leveler that has been mixed so that the material can be poured for a smaller application. And you can see that even though it is not as thin as water, it does find a measure of flatness. It does find the corners, even without moving it. Gravity itself will help achieve that on the material of the appropriate viscosity. On the right side of the screen, what you see is a large-scale pumping operation where, excuse me, let me get the right one to run. If you look at the material coming out of that hose and the way it's hitting the material that's already placed, it is a highly fluid, almost water-like consistency. And yes, that product is designed to be placed at that fluid consistency and will still get thousands of PSI within a matter of hours. Okay, quick discussion on patching versus self-leveling. There's 2 types of patching processes that are used more often than not. Skimming is used for flooring that is resilient flooring, let's say vinyl tile, LVT, and so forth, where every imperfection is shown through the millimeters of plastic that these vinyl floors are. We generally don't see that fine of a skim in a tile application where you're talking about millimeters. However, patching is employed anytime that we need to, let's say our substrate is a wood substrate and we have to fill in seams that we wouldn't want the self-leveling to flow through, or we have to build a ramp, or we have to locally slope to a drain. We would use a patching material that can accomplish that, because those are trowelable materials that are thicker, much like mud. They can be shaped and sloped as opposed to the self-leveling, which is more used to get an overall flatness across a large area. So the steps to providing this proper surface are easy, but have to be performed, and there's really no skipping steps. We'll talk about each one of these in a little bit of detail. We've already discussed the flatness or level required for the application and what determines it, the substrate itself, and the size of the tile. We have to make sure that our concrete slab or any substrate really is strong enough to be able to take the application. It does now matter more than ever to determine the allowable moisture for a particular application, even though tile is the single most tolerant type of flooring for moisture. There are certain types of installations where we do have to look at the moisture. The substrate needs to be prepared prior to the application of the self-leveling. It needs to be clean, porous, sometimes mechanically prepped. Elevations need to be measured and marked. And finally, the self-leveling can be mixed, pumped, and poured. What you see here is a very standard tensile pull piece of test apparatus that can be used for a number of things. In this case, it's testing the adhesion of a coating to a self-leveling, and it is also testing the adhesion of the self-leveling to the substrate itself. On occasion, we have to use that type of testing because we are going over a questionable substrate. For example, one of the questions that I get asked very often is, can cement-based self-leveling be used over a gypsum previously patched or previously flattened floor that's used a gypsum product? We in our industry avoid gypsum products for the very simple reason that they are not necessarily as strong or robust as the cement-based self-leveling or highly flowable mortars. So the first thing that we do is we actually prepare the gypsum prior to the installation of the cement-based self-leveling and then test for the bond. Depending on the manufacturer of the cement-based material that's going over the top of the gypsum, there are various specifications that will say, for example, 100 psi of tensile strength is required for a manufacturer to feel comfortable to put their own product over the top of that. The moisture comes in when specific types of applications that you might run into that are listed here. Gauged porcelain panels can be very non-porous, and the vast expanse of area is one that can capture moisture, particularly in a slab-on-grade area where you have hydraulic pressure as well as just moisture. Moisture doesn't affect insects, muds, and so forth. Epoxy grouts, non-porous to moisture. Any type of non-porous tiles, such as epoxy tile, terrazzo tile, and so forth, the NTCA does give a more comprehensive, more definitive list in this, but I wanted you to be thinking in terms of, as we progress with what we're doing, there are considerations that we normally would not have had to think about, and moisture is definitely one of them. Elevations can be measured in a number of ways. The typical and most common is probably a laser, where a story pole is used. The laser puts out a rotating beam of light that sweeps across the room. Somebody is standing at the area where the elevation needs to be taken, and the light hits this measuring pole where the elevation needs to be. And what you see as little white tabs on the concrete substrate that we're looking at on the picture with the laser in it are self-adhered tabs that can be cut to length, and excuse me, they can be cut to the height of the requirements for the self-leveling, where essentially in our pour, the material is poured right over the very top of those measuring tabs, making them disappear. The ease at which this happens is pretty good. It helps to prime the floor first in order for those tabs to adhere better. Another way of measuring is what you see on the left side, which is a hydraulic type of a level that essentially you set down what you see the mechanic holding that apparatus, that rod with the reading display on the top of it, set a 0 and then measure every few feet depending on how much flatness is required. The more measurements, the flatter floor that can be achieved. I've seen floors with flatness of FFs in the 80s with measurements taken every 3 feet. And again, the same type of tab is used to place periodically where the measurements are taken. The advantage of using something like a NIF comp is very simple. The hydraulic liquid that is inside that yellow tube that you see does not need a direct line of sight. So on a piece of equipment like this, you'll have about 75 feet of a radius, and you can go into individual rooms without needing to move something like a laser, which cannot be blocked. The light cannot be blocked. All right, I did this a while ago, and I included it in some presentations because, well, frankly, because it's fun. But this is And this is my Neanderthal way after having taken the quantitative measurements, just taking out some pent-up aggressions and hitting some self-leveling underlayment that was placed over a gypsum substrate just to see. And you know what? I'm going to replay this again, but with the sound, so you can see that it was getting a pretty good whack, and it didn't despond. So yes, we can and quite often repair questionable substrates as well as making them flat. Okay, so the substrate is prepared for a few different reasons. It must always be clean, and you all know this. Cement-based products, polymer products, resinous products do not like sticking to dirt. They come loose. So the dust needs to be gone, the dirt needs to be gone, the stuck on paint, coatings, and sealers all need to be gone. The typical self-leveling application does require a primer. The primer does two things. One, it enhances the bond between the self-leveler and the material that it is bonding to the substrate below it, but it also prevents outgassing. What outgassing is that there can be air bubbles that come through a concrete substrate. Concrete is strong, but it is porous. That's why it has moisture in it. That's why it has gases in it. Sometimes those will come out through the leveling. So when the primer is placed and allowed to dry properly, the outgassing is prevented to a very large degree. Some self-leveling underlayments do require mechanical profiling. CSP is a degree of measure that's given by the International Concrete Repair Institute, and there are actual little rubber models that show what a CSP 1, 2, and so forth are. Not all self-leveling requires a mechanical profile. That is important to say. Sometimes you need porosity, sometimes you just need cleanliness. What I have found in my own experience is that if a concrete has been down, even if the material does not require mechanical profiling, a quick CSP1, either brush blast or light grind, is often necessary to remove some of the contaminants that are found on the floor itself, and is a good way. Keep in mind, different principles and different types of profiling are achieved by using a grinder versus a shot blasting machine. The shot blaster has more mountain-like peaks and valleys as opposed to the ridges formed by a grinding, but both can do very good, very acceptable surface preparation. Priming, a couple more details. On a smooth concrete floor that has been steel troweled, primer should be rolled with a medium nap roller. It gets the spread much better. A rough floor, a rough substrate like what you see here, requires the use of a broom to scrub into the rough in concrete. Now, I've had contractors tell me that they like to use a broom either on even on a very smooth surface because they find that they can work it in better with a broom. That is something that is not mandated one way or the other, but these are the different methods of applying the primer. The typical amount of time it takes a primer to dry can be 2 to 4 hours. They're usually acrylic or latex-based materials that are water-based. So the question, well, how long exactly does it take for your primer to dry is like saying, how long does it take for water to dry? Is it in a glass? Is it poured on a floor? Is it on a very porous substrate? Is it 90 degrees and dry? Or is it 50 degrees and wet, which is the weather that I'm seeing in Wales over the last couple of days. By the way, that black residue that you see on that particular concrete substrate is adhesive cutback, not non-water soluble adhesive, can be primed over if you get it to a condition where all the bulk adhesive adhesive is removed. Just something to keep in mind. One more thing that can be done. And these are the kinds of questions that you want to be thinking about. Not only what is the condition of the concrete, but what's on it, what needs to be removed, what does the self-leveling product require for a surface, what are the warranties, and is the surface prep required change depending on the time level of the warranty. Pour stops are something that I just wanted to touch upon quickly. Often we have applications, installations where we're pouring over large, vast, wide open areas where it would be very difficult to control the flow of a self-leveling material. And what is done in cases like this is either dimensional lumber or sometimes aluminum angles, and you'll see the aluminum angles in a picture a little further down, are used to control the flow of the material in a tighter, more confined space. So we essentially subdivide it into strips that can be 6 feet wide. That's just an example, depending on the space. And then sometimes we'll have cross pieces that go across the length that even further cut down on the area which is being leveled at once, or flattened at once, I should say. The reason for dividing into even smaller areas is that sometimes we have dramatic elevation differences in a floor where maybe we can control a little bit with a minor slope. A self-leveling can actually be sloped, and this is just an example of some of these materials. You could probably control it to do a 1/4 inch drop every 10 feet. I'm not talking about deviation. Please don't confuse the deviations that we discussed earlier with the amount of sloping that can be done on a self-leveling. So it is a material that wants to flatten, but the slope can be controlled at about a 1/4 inch every 10 feet when you have the material in a confined area rather than a wide open space where all it wants to do is run and run and run, and the mechanics are then chasing it and trying to bring it back, causing for a difficult, costlier, and less effective application. Okay, I'm going to give you the idea of some tools of placing self-leveling depending on the size of the job. And there's no black and white. So typically what we see is a standard tool kit with a mixing bucket that'll hold 1 or 2 bags of material, no more than that. If you consider the fact that you're mixing most materials 3 minutes, you're getting at most a mix of 1 bag every 2 to 3 minutes. And then the barrel needs to be employed to pour it out into the area that's being leveled. So you would use a second bucket, and in that way, you probably get about 40 bags an hour, maybe a little bit more with a crew that is highly in tune with using this particular method. By the way, it is a very effective way of pouring self-leveling when you're doing individual rooms. So even if you have a lot of square footage, if it's not a wide open area, you don't necessarily need to use a pump. The next stage would be a portable mixing station with wheels. The one that you see here will actually tip over. It'll take 3 bags. Some of the larger units may take 4, but let's say 3. So here you're getting easily 60 bags an hour that can be poured out of a tipping mixing station. A smaller mixing pump offers the advantage of a greater amount of speed up until 180 bags an hour. Some of the newer pumps do even more than that. The water is pre-calibrated, so as long as that material is in the hopper and the water supply does not change, assuming a good calibration and all the mechanical parameters are working properly, it's a pretty steady, continuous operation that can give us 180 bags an hour. And the final for the largest of the large jobs are truck-mounted pumps that can pump up to 600 bags an hour, up to 30 stories up in the air. That high flow, high capacity flow that I showed you in the picture in the little video before was actually on the 40th story of a high-rise in New York that was being pumped up by a truck similar to the one in the picture. And it was being pumped through a stage pump that looks like the stage 3 pump that then pumped it up the subsequent stories. The point here being that there are placement methods that are appropriate for every single job that's out there, whether you're doing 200 or 2 million square feet. No such thing as too large or too small of a placement. And here's what a portable mixing station looks in action. This was done in a hospital, new construction of a wing, where even though there were thousands upon thousands of square feet to be poured, it didn't make sense in all the areas to use a pump. By the way, one of the things that I should point out about pumps is 99% of the time they're either 230 volt or 480 volt 3-phase machines. They require trained operators. There's more of a cleanup. So they're great to use in the very large jobs, but don't think that you can't be effective in placement and effectively make money by using something like a portable mixing station or even little blue mixing barrels. Just something to keep in mind. Size it accordingly to the job and use the consultative advice that the manufacturers can give you. Okay. Once the material is poured, unlike concrete or mortars, it does not get trapped. All that is necessary is to break the surface tension so that we don't see bubbles and areas of stress in the material. The two most popular methods of achieving that are either by smoothing, and what you see over that white material is a mechanic using a smoother, and that, by the way, that's our own Eric Puchalaski, our original VP for the North. He's so photogenic, I had to put him in this presentation. So Eric, if you're there, hello. And essentially it looks like a plaster knife at the end of a handle, which is dragged across the surface gently but firmly enough to break up the bubbles and break the stress. Porcupine rollers are rollers that have spikes on them that can be up to 1 inch long and essentially put little holes in the material that immediately fills up and smooths it out. My recommendation would be the porcupine rollers are a really great way that doesn't require much skill at all, but are more suitable for applications that are 1/4 inch in thickness or less. If you start getting significantly thick, what ends up happening is the roller pulls the material instead of rolling through it, and that's where the smoother can be very handy. Anybody that's ever seen a gauge rake, that is a type of apparatus where you have a straight edge with 2 cams or lobes on the end set to a specified thickness. If we know that we're pouring enough of the leveling material that we will cover all of our high spots, and we don't want to do extensive measuring, and it's not required in the contract, let's say, to do extensive measuring, a gauge rake can be a useful tool. Please keep in mind, if there isn't enough self-leveling material, if the high spots overcome the thickness of the self-leveler, if the floor is particularly wavy, lumpy, or bumpy, the only thing that a gauge rake will achieve is to glide over the high spots and then just give us, a 1/4 inch or 3/8 of an inch thick self-leveling material that has not necessarily flattened that floor. Overlays absolutely positively have to be gauged with a rake, simply because when we're doing an overlay, we can't take the chance of our plastic tabs that we discussed previously, excuse me, showing through an overlay application. We're reaching towards the end, folks, so have your questions ready. I wanted to show you what an application looked like. This was time-lapse photography, and you can see, obviously, in fast motion, the floor had been laid out with pour stops that were in both directions where controllability is needed. The I know the more savvy you're going to ask the question, wait a minute, I just saw some material slide under that horizontally oriented pour stop. You are correct. What saves the application is that as long as the overall section is covering all the pins, then we have successfully met our thickness requirements to elevation to meet the flatness that we need. And sometimes when pouring very thick, like in this particular application, so you'll see the removal of the separation devices. A very thin 1/4 inch layer can be added because it makes it that much easier over many square feet and a thick leveling application, a thick flattening application, to simply have that final thin layer that is much easier to control and smooth. And you can see in fast motion there that the tops of the aluminum channels have been removed. You can no longer see the elevation pins, the plastic tabs that I was referring to, and what appears as little squares in the middle of the floor are I can't remember if they were junction boxes, electrical boxes, or so forth, something that needed to remain exposed. One question that is very typical is when putting down self-leveling in 2 layers, does it need primer? If you can catch it within a certain number of hours, and depends on the material, how many hours are allowed to lapse, some manufacturers, please check with your individual manufacturer, but some manufacturers will allow a second layer placed within hours not to use primer. Primer will never hurt, but we can sometimes forego the need on a second layer of self-leveling placed over the top of green self-leveling. So essentially, we start from a very rough, unflattened, unlevel floor to something that meets the requirements that are set forth by ANSI, that are recommended by the NPCA, to where we can place an amazing large format, small format, or any type of tile floor that we want to see. A question that I get also very often is, how quickly after the placement of the self-leveling can we put down tile? Because you'll see on the data sheets from the various manufacturers 2 different listings, one for tile and one for other types of flooring, particularly moisture sensitive flooring. Tile that is moisture forgiving and is placed with a mortar which also soaks up moisture can generally be placed within hours after the pouring of the self-leveling. Once the leveler is hard enough to be walked and worked on comfortably without leaving imprints, so that could be 2 hours, 3 hours, 4 hours, depending on the material and the circumstances, tile can be placed, unlike Brazilian flooring, which will often take 24, 48, 72 hours. By the way, all these figures that I am giving as examples are for cement-based self-leveling systems, not gypsum products, which tend to take a lot longer before they lose their moisture. So, having said that, I want to thank you. I hope you got some good information, and I'd like to open this up to questions. Before I do, that little QR code, which you should be able to pick up off your screen, if anybody wants my contact info, email, telephone number, and so forth, if I got to do it correctly, you should be able to scan that QR code right off of your own computer screens. Do we have questions?
Joe, great job. Lots of information. I want everyone to remember, you can watch this in the next 72 hours. We'll have this up on the NTCA YouTube site, and you can watch this to go over. I know it was a little bit hard to hear at a couple of times. It was kind of a tin can kind of echoing thing, but it was all okay, and it was good. So yeah,
for that.
It's okay. It's okay, Joe. These things happen when we're traveling halfway around the world, right? So let's get to some questions. So our first one is, Can a typical concrete contractor provide a 1/8 inch in 10 for new construction? Is there a difference between on-grade and elevated slabs? So two questions.
Man, oh man, somebody is really trying to get me in trouble because I have spent a good part of my career dealing with concrete contractors, and they're actually very, very good friends of mine. So if anybody is listening on the concrete side of things, don't take this the wrong way. I have very rarely seen a slab of concrete that is an 1/8 in 10. I might even say never. And keep in mind, by the way, part of it is that the specification itself doesn't even require that. So it's a very difficult thing to get with concrete itself unless some very sophisticated technological methods are used. Basically, you would have to use some type of a laser screed. And even then, corrective measurements are very often required. Yes, there is a difference between slab on grade and elevated slabs, particularly.
Hey, before you get to that, Joe, I just want to say to the first part of that answer, it would be an accident if you actually got an 1/8 inch on 10 foot. So very difficult, definitely. That's why we do these self-leveler or self-flatteners and products. So go ahead. I'm sorry.
No, I'm glad you said that because I'll put it in a slightly different way that says the same thing. I wouldn't have a job. If concrete could be brought to an 1/8 and 10 on a typical basis, you certainly wouldn't need me or these materials. So hey, maybe I'm a little thankful about that. You know,
Yeah.
opportunity. The difference between an elevated slab and a slab on grade is that after you place the elevated slab, it can actually depress and sink because of the dead loads of the slab itself. Slabs can curl, which is more typical on an elevated slab. And by curling, what we mean is a shrinkage that pulls at the edges of the concrete, and the material wants to go towards its center. Sometimes it will crack the concrete, and often it will leave a depression in the middle of the slab. Slabs on grade have the advantage of having a support underneath the slab, but they have other challenges. With slabs on grade, we have the moisture that can be coming up through an improperly applied vapor barrier, which is more typical than not. I hear the echo, by the way, and again, I apologize. I'm going to try see if I move a little bit. That'll help it. I hope it does. So no, 1/8 of an inch is not something that you're going to achieve on a regular or even a rare basis.
Great. Just want to say this to everyone before we go further, Joe. Everybody should check the recommendations of the manufacturer they're using, right? Because there are differences for each one of them, and they all have technical hotlines, people you can call, your distributor and their salespeople, but make sure you're using the correct information for the product you're using. It's so important, definitely. All right. What tools and equipment and supplies are required for installing self-level? Is it very different from the stuff you need to install mud beds and thin sets? What's a good way to get started at this skill?
The very first thing that should be done is to have a sit down with the technical people of the manufacturer or manufacturers that you are dealing with to get a better, fuller answer for that. The tools are somewhat different because when we're installing tile and using a mortar that has a consistency, what do we want in a mortar? In a mortar, we want a product that we mix it and it keeps its ridges, it keeps its shape, but is squashable when the tile is put on top of it. With self-leveling, we're looking for a material that is fluid, from very fluid to very, very fluid. So the mixing apparatus may be the same, although different types of mixing heads are used. Let's say you're using a drill and paddle mixer, the paddle would be different. Or more than likely, we're going to be using either a mixing station, which the drill and the paddle are all part of the machine. That too can be used for mud beds or for mortars. These smoothing tools are not typically used for installation mortars. So you're not going to use a smoother. You're going to use a notch trowel and a flat trowel, which are two items that you would not use for the installation of a self-leveling. The barrier of entry to the business is not a high one. The tools are readily available. For example, most manufacturers, ourselves included, sell kits for the smaller jobs, which include the mixing barrel, the spiked shoes that are used to walk through the material, a smoother, a roller, a gauge rake, and an appropriate size and appropriate dimension paddle. So
Joe,
it's
Joe,
fairly.
let me jump in here real quick. So I want you to know all these manufacturers go around to their distributors and they do demos on all of this. They'll talk about the products, they'll talk about the tools, they'll talk about even the cost to get involved by buying those tools. NTCA goes around the country and we do workshops, and one of our workshops is on flowable self-level products like this. And they will actually let you use the tools, go through the process. It's a hands-on program. I would just say, talk to your distributor, local distributor, go to the NTCA's website or Laticrete's or any one of the manufacturers, and they have a whole list of where they're going to go, where we'll be when we're doing these programs. And I think it's important to go to these free programs and learn how it's done. It's easier than we can talk to you about all the different stuff, but until you see it, put it in your hand and use it, you'll really understand it that way, Joe. I didn't mean to step on your toes there, but I think the people can really take advantage of these free programs. So definitely.
And that's where I was going to end up with that. There are numerous demos, and you guys do an amazing job. The manufacturers do a great job. Hands-on is hands-on. There's no replacing it.
So this next question goes right along with that. So are there any special considerations when going over plywood, these self-levelers?
Absolutely, positively. First of all, the biggest consideration is that do not ever think that the self-leveling is going to add stiffness to the floor. So whatever the stiffness requirements, the L over 360, L over 480, L over 720, which are all stiffness requirements for a subfloor, don't think that because you're going to put in a ½ inch of self-leveling, that's going to give you more stiffness. The second part to that answer is that depending on the product itself, there may be mechanical attachment requirements to put a self-leveling over a wood floor, over a wood subfloor, plywood subfloor. By the way, the wood that you're going over needs to be exterior grade and be able to take moisture, because what are we putting? We're putting wet primer, we're putting wet cement. So that quality has to be met. There's no exceptions to that. Most manufacturers will tell you don't go over particle board. The seams between the pieces of plywood need to be sealed so that this very liquidy material doesn't run out between the seams. And that's also a good point to make. Anywhere where there's a potential for material to leak out, seep out, any small holes are large enough. If water will get through it, there's a very good potential that self-leveling cement-based underlayments will get through it. So if there is a particular product that you're using that does not require the use of metal lath or plastic lath, it's because it has the appropriate amount of raw materials in it to make it even stickier, even more flex to it so that it can go over wood directly. So there are concerns, yes.
In a residential new construction, what are your thoughts on doing an FHCU pour before framing?
I've seen them done both ways. So when you do it when there's a wide open floor to pour over, it gives ease of access. A pump can go anywhere. The person holding the hose can walk through the entire application. That does not mean, however, necessarily that it is an easier, faster application. As I showed before, sometimes it's so wide open that you have to control the flow of the material, so you end up putting, essentially, these pore stops are artificial framing. They're types of forms to control the flow. It's not always the most difficult thing to go from room to room if the walls are already up, to put the self-leveling. The other thing that's very, very important is, much as we would like to be able to get the self-leveling out of the way, and sometimes it's done that way, is there are environmental considerations. If you are, and it's not just residential, by the way, Jim, right? I mean, commercial applications that are concrete superstructures very often have that same question. Do I put up the walls and floors first, or how to achieve this? And essentially, the material needs to be protected from the weather. Some materials are 48 hours, some are 24, some are 4. All of that needs to be taken into consideration. So there's no clear-cut answer, but it can be done either way with the proper methodology and precaution.
All right, well, it looks like we are done for today. And I want to thank you, Joe. I want to thank all of you that stayed on to the end here. Remember, this will be on by Friday. It will be on the NTCA YouTube channel, and you can review it at any time or share it with anyone. I want to thank Laticrete for presenting this, and Joe, your time here. I want everyone to know that April 25th will be our next webinar, and that is the Tuesday right after coverings. So once you get back from coverings, you can just jump right into a webinar. That'll be great. So thanks, everyone. Have a great week, and we'll talk to you later. Thanks, Joe.
Thank you. I appreciate the fine work that you guys do, and real pleasure and honor to be here. Have a wonderful day.